Hello, can you hear me?
জি স্যার, শুনতে পাচ্ছি।
The audio? Yes, you okay?
স্যার ভালো, আলহামদুলিল্লাহ।
Good. So you joined 67. So how about the others people? They're still trying or? Okay, anyway, I think we can start rather than waiting for some mood to join. So I think in the last Sunday you missed the class, isn't it? I think I'm just a little bit lagging behind you. Did I discuss pit latrine design with you? Exercise example? Can anyone recall what is being discussed? Did I discuss design example of pit latrines or on-site excreta management system? Any design example with your class?
No, sir, there was no design problem.
Okay. Then you missed one class, I think. Yes, I'm right. Because I discussed with other section. Have you got the lecture material for design of pit latrine? Did I upload?
No, sir.
No. Okay. So then what is planned today? Today we'll very quickly we'll have a look on the design of pit latrine, design example, exercise, factors to be considered with one or two example, and then we'll move into the treatment. So that is our main priority, wastewater treatment concept. So let's see how we move on. Probably trying to more emphasize on, yeah, I will do that. Today and also I have a meeting at 11:30. So yeah, let's see. I mean, let's start with record. Okay, just put my record on. So let's discuss about design of pit latrine. I will back to the slide now to discuss. So let me open the window. So you can see the window, yes? Okay.
Yes, sir, দেখতে পাচ্ছি।
Okay. Design is not really a big issue. I mean, it's quite simple approach of design pit latrines. What is important here to know about some of the aspects before you design as a final year student. So you always expect that you knows exactly the design consideration factors affecting the design and how to rationally assume the data if something is not given, informations are not given. So that is basically the facts of this slide. So let's move ahead. What is here? As you see, first of all, what is the technical factors affecting excreta disposal? So which is technical factor means as a technical guy or as a technical person, you are what basically you expect the factors affecting the disposal. Obviously, before that, we need to know how much waste basically we are generating, what are their types, and how it varies. Because once we know the design, basically, let's say for Bangladesh, this may not work maybe for other countries, even for Bangladesh, some people living in, let's say, slum area, some people living in rural area, some people living in uh, urban area, they're quite different because it's basically human waste, as you know, it's the excreta. So the volume is basically varied significantly, considering the water consumptions, climate, diet, occupation. So there are many varieties of factors affecting the volume it may generate. So the only way to obtain an accurate determination of amount at a particular location is direct measurement. So you go there and you measure, you talk to the people, about the water consumption, about the climate, what type of food they are eating day-to-day basis. So that is basically the information you have to count. As you can see in the literature, it is said that this is quite varieties of range, starting from 500 gram to 900 per person per day. This is just just an example or figure taken from the literature. As you can, just to give you the idea that it's quite wide range. If you think 500, then if you go to the 900, it's almost double the range. And there are some other notes. Generally, active adults eating a high fiber diet and living in a rural area produce more faces than children or elderly people living in urban areas eating a low fiber diet. So nowadays we are most familiar with fast food. Fast food is low fiber diet. This means less faces. Those people who are eating rice, a lot of vegetables, so they generate more. Generally vegetarian generate more faces. The total amount of excreta, it's just a thumb rule. You have to know. I mean, if information is missing, then how we basically accommodate or how we get the information available for design. So that is the total amount of excreta is about 1 liter per person per day. This is just a suggestion, right? It's not that accurate. This is about the feces, and this is about the urine. So the amount of urine is greatly dependent on temperature and humidity, as you always know. It's varied with summer, then winter, maybe. Commonly the variation is significant, and in that case commonly ranging from 0.6 to 1.1 liters per person per day. So that is few data available in literature by various research studies. So I just summarize few of these things. If you take a note, then it will help you to solve the exercise if data are not given. So then in that case, you can assume data rationally based on the reference given here. In absence of local information, the following figures are suggested as reasonable average. Like high protein diet in a temperate climate, feces 120 gram, urine 1.21 per person per day, as you can see. So if there is no data, then if temperature is temperate climate, high protein diet is the diet, then in that case you can assume. Vegetarian diet in a tropical climate like in our country, for example, or maybe South Indian side where vegetarian people are quite a lot, then you can see this faces is 400 grams. It's almost 3 times, more than 3 times. Urine is 1.01 per person per day. So these are the slide where you can see that some of the informations are collated for you. In absence of any data, then you can assume that. Then another factor is how the feces or urine decompose, basically. So when we dig out the hole, when we start doing the pit, then our main objective is to degrade the feces and urine biologically. And how we do that? What are the processes taking place in that case? So we have to understand, because that is also one of the major aims or objectives we set when we do the design of toilet. So that, as you can see, as soon as the excreta deposited, they start to decompose, basically, eventually becoming a stable material with no unpleasant smell and containing valuable plant nutrients, particularly nitrates. Huge amount of nitrate present in the urine, as you know, and also some of the diet we are, I mean, eating like fats or proteins or something, so also comes out through the excreta. During the decomposition, the following processes are taking place. For example, complex organic compounds such as proteins, then urea are breaking down into simpler and more stable forms. So that is, for example, let's say some of the protein is organic compounds like C12, starting with C12, ACE12, or for example, O23 or C6, ACE12, O6 is aminoacetic acid. So there are a lot of proteins. It's quite complicated, and due to the process is going through the metabolism, it's just breaking down into simpler and more stable form so that it can be taken care by naturally or biological process. So this is one of the things. And during this decomposition, some of the gases are produced, such as ammonia, methane, carbon dioxide, nitrogens. And basically, if you are not capturing those, it basically goes back to the atmosphere. And nowadays, in the developed countries, what they are doing, they realized that there are a lot of nitrogen, there are a lot of methane, there are a lot of carbon is being produced from the decomposition of the feces and urine, and that can be, if we can capture those, that is really an asset as of many other purposes. So it means not only just cleaning or decomposing the feces and urine, but also producing some of the material or some of the gases or some of the compounds which really can help, that may help to produce, some of the useful gases or nutrients that can be captured and used later on. Soluble material is produced which may leach into the underlying or surrounding soils or be washed away by flushing water or groundwater. So what other thing is happening? Some of the insoluble matter becomes soluble, and when it comes into the soluble, then it leads with the groundwater. I mean, it's leads with water, and then it washed away, flushing by groundwater. So it joined into the groundwater. So these also been happening at the same time. As you know, some of the pathogens, because why we say this is disease producing or this is disease causing things happening with feces and urine or excreta, because a lot of pathogens are present. These pathogens are carrier of diseases basically. And these pathogens, commonly fecal coliform, coliform, or various forms of coliform, helminthes, viruses, etc. These are destroyed because they are unable to survive in the environment of the decomposing matter. Normally, you think that they can survive well in your intestine, in your belly, in your stomach, because the stomach temperature is very much favorable for them to generate. When it comes out in the environment, sometimes heat is being produced, some other air comes out, then presence of air, presence of temperature sometimes does not create the good environment for pathogens to survive. In that case, pathogens also start destroyed in enabling environment in the once that comes out from your stomach. The decomposition is mainly carried out by bacteria. We'll talk about this quite a lot when we go for the treatment. So when we discuss about the wastewater treatment, then we'll talk about quite a lot about this. So this decomposition mainly carried out by bacteria. Although fungi and other organisms may assist, like sometimes algae, some of the viruses, but mostly bacteria. 99% cases is bacteria. This bacterial activity can be either aerobic, as I said, aerobic means in presence of oxygen, in presence of air. So it's taking place, we call aerobic. As you can see, it's called aerobic. And another is called anaerobic, which contain no air or free oxygen. For example, sludge underwater. So that water cannot allow what air to go through. So this is called anaerobic, like septic sludge at the bottom of the pit. So it's no chance air can go there. So in that case, that is called anaerobic. Quite interestingly, in some situations where both aerobic and anaerobic condition may apply in churn. For example, in the top layer there is oxygen. Then when all available oxygen has been used by the aerobic bacteria, then one form of bacteria. So you know two form of bacteria: aerobic bacteria, anaerobic bacteria. There is a in middle another bacteria called facultative bacteria. Facultative bacteria can survive with aerobic condition as well as anaerobic condition. So what they are doing, facultative, when all the available oxygen has been used up by the aerobic bacteria, then facultative bacteria capable of either aerobic or anaerobic activity, and finally it turns into anaerobic. Then it becomes anaerobic, basically. So that is basically the fact how bacteria basically. So what basically is there? So in our excreta, basically we have organic matter, we have protein, we have fats, we have starch, we have carbohydrate, depending on the diet we are consuming. So this is quite complicated form, and these bacteria basically taking those complicated organic compound as their food. So that is basically the huge motivation. So this means that if we can culture those useful bacteria, then that bacteria can basically clean our waste, because what we call waste, they take it as their food. And while they are taking their food, they survive, and ultimately when there's a shortage of food, bacteria also die, and this is how they clean basically the solid and liquid. So it's quite interesting. Pathogen may be destroyed because of the temperature and moisture content of the decomposing material, create a very hostile condition for destruction. For example, during composting of a mixture of feces and vegetable waste under fully aerobic conditions, the temperature may rise to 70 degrees Celsius, which is too hot for the survival of intestine organism. Because the organism present in your stomach, basically in your stomach temperature varies normally 25 to 30 degrees Celsius, sometimes 35. When it comes out, if it is a very hot weather, particularly any temperature above 55, normally they cannot survive. So what basically happening in that case, these pathogens also need food. When they comes out with the feces, they also fighting with the bacteria, as you know, the bacteria basically eating the organic. So they need also bacteria, organic matter as their food to be growing up, the pathogens. And pathogens basically try to fight with the bacteria present, and they have basically in a where they start fighting each other, and sometimes they lost because of the limited nutrient present and because of their strength. So this is quite interesting biological formulation or biological cases by which basically the destruction is happening. So now coming back to the volume again. So as you can see that when these volumes basically decompose, then what is happening in the process of decomposing? So we can see that there is a reduction of volume and mass is happening. Why? Because of the evaporation of the moisture, because there are a lot of water present, and then it evaporates sometimes. The production of gases, as you can see, methane, carbon dioxide, nitrogen, they also escape to the atmosphere. So this is how the weight is reduced. Some insoluble material become soluble, so they soluble into the water and the leaches go back to the groundwater. So this is how volume is reduced, also mass is reduced. And some of the transport of insoluble material by surrounding liquids and consolidation at the bottom of the pits, you know, the consolidation from your geotechnical engineering, and that is happening because of the weight and under the weight of superimposed solids and liquids. So some compactness is happening. So this is how also volume is reduced. And this is basically some of the suggested maximum sludge accumulation rate, liters per person per year. So this is yearly basis, remember, it's not daily basis. So these are the table. Sometimes we give in the exam, sometimes we do not give, but it is easy to remember. As you can see, there are three figures here basically. So 40, 60, 90. What are the criteria? It says the criteria is basically waste retained in water where degradable anal cleansing materials are used. So there is no water, but waste retained in water. For anal cleansing, we use some, for example, tissue is degradable or biodegradable, or some sort of newspaper or something like that is degradable. Another cases is very similar, waste retained in water. So it's first two is retained in water, where non-degradable anal cleaning materials are used, which is not degradable. If this is the case, then sludge accumulation rate is 60. If it's degradable, then it's 40. But waste retained in water, that means, for example, let's say groundwater table is high, then sludge go directly under the water. So that means sludge or waste is retained in water. So it's a moist form basically. Then we have two figure, 40 and 60. It depends on the what is the cleaning material we are using, whether it is biodegradable or not. If it is wet written in dry condition, so it's very similar to number 1 and 2. So then waste written in water, waste written in dry. So last two is the dry condition. And same as before, where degradable anal cleansing materials are used, then 60. When non-degradable anal cleansing materials are used, then 90. So then we can understand that if sludge is retained in water, then they have faster biodegradation. Because of the anaerobic digestion is much faster, sometimes slow, but for decomposition is much faster. So that's why the rate is quite low, and if it is the dry, then rate is quite high. When designing a latrine, then it is strongly recommended that local sludge accumulation rates should be measured. So it is recommended that you measure the local sludge accumulation rates. Local sludge accumulation rate means you go to the locality where this design will be placed, and then you talk to the people about their diet system, about their water use, whether they use water or not. So depending on that, so that's what it says. It's strongly recommended. But in the second line paragraph, however, in absence of local data, the volumes given in the table as seen previous, I mean, you have seen just as I suggested as the maximum. That is maximum. So there is some evidence to indicate that these figures are on high side. However, if refuse is added to the excreta, the accumulation rate may much greater. So sometimes the toilet is not only used for toilet purpose. In many cases, toilet is also used to dump many of the solid waste, some of the refuses. Sometimes people also use as a shower for their toilet. So if this is the case, then reduction, I mean, the rate might increase. So that is basically meant for that line. Where excreta are stored for a short periods only, such as in a double pit latrines or composting latrine. This means that if you use double pit, or if you design for your latrine for 1 to 3 years or 5 years period, in some cases complete digestion or complete decomposition may not take place. In that case, it is necessary to increase the amount by some factor. So sludge accumulation rate is 50% increase is tentatively suggested. So it varies. I mean, it's a kind of thumb rule. Some people prefer to give 30% increment, some people prefer to give 3%. So this is all about the volume of phases. You can see, I mean, what is basically depending on the human consumption of water and food and climate and everything. So now you have to check the ground condition, because one of the main objective doing the pit latrine is allowing the water to infiltrate so that water can also treat. And also another is the ground conditions support your latrine or not. So this is very important. So ground condition affects the selection and size of the design of the sanitary, because if soil doesn't have a good bearing capacity, then we may not go for 1 to 1.5 meter circular or square or rectangular shape as we discussed earlier, as you can see. So in that case, bearing capacity is important because it must be supported by the soil, and sometimes self-supporting pit. If we do not do the lining, then obviously the supporting pit is self-supporting. So whether self-supporting pit properties against the collapse, you have to check. Depth of excavation possible. Whether it is a rocky soil, then it is not possible to dig out the pit. Basically, so depth of excavation is not possible. So sometimes it's very loose sand, depth of excavation is not possible also. So that is few things. And also you need to check the infiltration rate, whether too fast infiltration is not allowed, as you know, and too slow infiltration is also not allowed. So whether infiltration rate is quite favorable to do that or not. And one of the many aspects of pit latrine is the groundwater pollution risk, particularly when groundwater is used for potable purposes as well as non-potable purposes. We discussed already what should be done to protect the groundwater pollution risk in your class. So these are few things we have to keep in mind as of this. And this is another table, as you can see, recommended infiltration capacities for settled switch without polluting the environment. So if it is a coarse or medium sand, obviously it's 50 liter per square meter area per day, and then it's going down as you move to the finer fraction of the soil is going down. Even for the clay, as you can see, even less than 10, which is not really a good options to go for that. So up to 20, I should say, we should at least maintain. Otherwise, it's quite unusual because of the water use, because of your urine, because of the solid present. It might fill up your pit quite a lot, and you can see the surface leakage. So surface leakage is not at all allowed. So that's why. So these are few tables. Just keep in your head about the little bit of the figure, the way you can memorize. You can find your best way to look at. Although memorization is not really recommended, but at this moment, just to give you the idea that okay, if this is the soil type, then we know this is the 50 liter per square meter per day. If this is the soil, then it should be reduced. If there is no hard and fast, you have to use 50, then it means close to 50, close to 30, close to 25, then 20, maybe 10. So this is what is recommended. And finally, you have to check the groundwater pollution risk, because this is one of the major area nowadays why basically we are not recommended pit latrine basically. Because the effluent from the pits and drainage trench may contain pathogens, some of the chemical substances that could contaminate drinking water supply. Of the chemical substances generally present in domestic waste, only nitrate present the serious health dangers. The nitrate is very, very hazardous. As you can see, young babies bottle fed with milk made from water with high nitrate concentration may develop blue baby syndrome, sometimes we call blue baby disease or methemoglobinemia, anemia, which basically fighting with the hemoglobin, and they reduce the hemoglobin level. And then if they reduce the hemoglobin level, the baby skin or baby looks like bluish color. So then you can feel that the baby is having high nitrate concentration. So this is can be fatal if untreated. And there is another conflict. Evidence suggests that even low concentration may contribute to gastric cancer. So it's some range is there. I mean, if you treat it, you can have some range recommended by the authority. like DOE or maybe USCPA or WHO, for example. In the third paragraph, we are showing you that the usual means by which effluents affect drinking water supply is through the pollution of groundwater that feeds well and boreholes. A further danger is when effluent infiltrates the ground at a shallow depth near to water pipes in which there is an intermittent flow or in which the pressure is at times very low. Sometimes in our cases in the city of like Dhaka or Chittagong or major cities in Bangladesh, so the pipe is not always carrying the water. So it's sometimes intermittent flow. So at that time, pipes are empty. There is negative pressure being developed. So negative pressure is always harmful. They produce some sort of cavitation, some sort of the leakage, and they attract then the wastewater basically. So there is a chance of pollution in this case. So that is what is being said here. So now about we discuss about the factors basically affecting the design. So now we will go back to the design example, how to basically calculate or design the pit latrine. Obviously, our major intention is to look into the hole or pit because superstructure can be made with available superstructure material. But at this moment, I just go back to you to hear from you some of the feedbacks or something you may not clear or something still we can discuss before we just go back to the more on mathematical form of design basically. So do you have anything in your mind or anything you want to ask? Because once we finish this chapter today, probably today we'll finish, then we'll go for maybe sort of quiz or class test or maybe assignment. So we are thinking of. So any question in your mind you want to ask or anything still not very clear? Or any comments from your side? Hello?
স্যার ইনফিল্ট্রেশন ক্যাপাসিটি চার্টটা তো মুখস্থ করা লাগবে না, তাই না? তার আগেরটা খালি লাগবে।
Right now, it's better if you can keep some data on your head. I mean, I preferably because it's not something about the memorization. Basically, it's something about the understanding. For example, coarse sand or medium sand have more infiltration capacity because their pore size is much higher compared to the clay. So if you understand this sort of data by reading the table, so that will be fine. I mean, that is my point. So that if I sometimes give you the in the exercise or in the example, okay, this is the sand is let's say fine to medium coarse, for example, then you know exactly the value might be close to 35 or 30 or something like that. And if I give you the medium or coarse, then you know this value must be more than 30. So that is what is my understanding. It's not like I'm just keeping my head busy with just memorizing a lot of data, because data can be available in the design. If still in the exam, if I'm not providing this data, then what you will do? Obviously, you have to assume some of the data. So you know exactly the clay is less pervious, sand is more pervious, then how this danger went. As a designer, you are designer, let's say some of your friends are designer, and design can be varied. 100 people design same thing can have 100 outcomes. But all of the designer must have their justification. So why I am keeping this value, why I am adopting this value. So that is really important. So that is the point I want to highlight or mention. Anything else? So are you sleeping, just logging into the class, or you are here? Only I am alive with some of you. This is the case of online classes, or you are really hearing? You're hearing.
Yes, sir.
স্যার শুনতেছি।
Is there any other question? I'm always taking the notes. Who is asking me the question? You know, that is also necessary as per your class performance. So I'm not speaking. That doesn't mean I am hearing. If you hear, that means you have some question, obviously, in your mind. So I'm taking notes. Those who are responding in the class, who is asking the question, how many times you are asking question and respond. So that will help me to assess your understanding, because you are not in a physical class anyway. Okay, so if you do not have any question, then we might proceed in the design. Okay, so in the design, please keep your calculator ready, and I might ask randomly the roll number, and then those who will be asked, and please discuss your comments or result, what you have been made. So let's go back to the slide again, once again. I'm going back to the slide. Oh, what is this slide? Okay, so can you see the slide again?
Yes, sir.
Okay, so as you can see here, now we move into the design example. So we normally, as I said, we normally discuss about the substructure, which is pit. How we do the sizing of the pit. Basically, when we calculating the dimensions of a hole or pit latrine, three conditions must be satisfied. So normally, as you know, the size of the pit can be mostly sometimes circular, sometimes we do the rectangular or square, depending on the soil type, depending on the equipment available, but mostly circular, if I should say. That's to reduce the spaces, availability of the spaces. The pit should have sufficient storage capacity, so that is important. So pit must have some sufficient storage capacity for all the sludge that will accumulate during its operational life or before its plant emptying. That means it depends on the design life, how we operate, for how long we design. If it is for 5 years, then it should have sufficient storage for 5 years, considering some other uncertainties also, because you never know during the operational phase. Sometimes, you know, we as an engineer, we do the design quite good, but when it comes into the operation, we never mention how to operate, and people are misusing it because they are not technical people. They do not know how to operate it, and they do not have any idea how to empty it, how to reuse it. So that is very important. So that sort of uncertainties are here. At the end of its operational life, there should still be sufficient space left for the contents to be covered with a sufficient depth of soil to prevent surface contamination with pathogenic organisms. What is said this point? At the end of its operational life, for example, we are not using this pit anymore or any longer. We're saying that there should be sufficient space left, so it's a vertical. No? So as you can see, can you see the things I have shown you in the figure? It is visible to you?
না স্যার ঠিক মতো বোঝা যাচ্ছে কিছু EGL
বোঝা যাচ্ছে এখানে ECL থেকে so this is the depth
স্যার আমরা দেখতে পাচ্ছি না।
for example D. I will take you to the board in the next class, so I will use sometimes board. Is this figure visible to you now?
No, sir.
Yes, sir.
Yes, sir.
Okay, I mean, if you can see the depth D, that will be fine. ECL means existing ground level, and the D from the ECL is, we said that is the highest level after end of operation. So that D is called soil seal depth, so which is the point 2 in the slide. Okay, so that means we do not want sludge or urine to come up to the surface level, so that there might be chance of surface contamination, leakage, bad odor, flies, etc. Because that pit will not be used, so that will be safe. And after 4 or 5 years, that sludge becomes soil. Okay, so that is the point. It says sufficient space left for the contents to be covered with sufficient depth of soil. So that is we call soil seal depth. So now you may ask, like, what is the value of D? Okay, we'll come back. How much, at least minimum value of D required to prevent surface contamination. And again, it depends on the soil type. Particularly if it is a clay soil, it's good because clay soil has less porosity or perviousness, so it will protect water to infiltrate above that level. So number 3, there should be sufficient wall area available at all times to enable any liquid in the pit to infiltrate the surrounding soil, because this is one of the major objective of pit latrine design. So try to take water out from the pit. So pit has circumferential area. That circumferential area basically allow water to infiltrate. So I'm just showing you this figure once again. If you can just have a look in the figure. I gave some arrow marks. So this arrow mark is basically wall area available to allow infiltration. So sometimes the vertical wall are lying, because depending on the soil, if soil cannot sustain the void, sometimes the vertical wall is being lying. So in that case, only bottom area is available for infiltration. In that case, infiltration area becomes lower. So that's why we want to make it unlying, so that enough area is available for water to infiltrate. But in some cases where there is a chance of groundwater pollution, when there is a the tube oil is very close to the pit, in that case sometimes we put some lining material. That lining material basically work in a two-way. It can also protect the vertical wall as a lining, and also protect infiltration, infiltrating the pollutants or contaminating the groundwater by reducing the infiltration basically. So they can be a protective layer basically. So that the number 3. So these 3 things, when you design a pit, you have to keep in mind that this must be satisfied. So now, as you can see, coming back to the mathematics, which is much more easy, and we always prefer as an engineer to do the calculation. So you can see that the storage volume required to accommodate the sludge that accumulate in pit during its operational life can be calculated by V is the volume. We put it in cubic meters. So equal to N is the effective life of the pit. P is the number of people using this pit each day. And R is the estimated sludge accumulation rate for a single person. As you know, per person per year, 40, 60, 90. These are the 3 figures you have seen in the tabular format already. So That is basically equation. So NPR. V is the effective volume, N is the effective life of the pit, and P is the average number of people who use this. So equation is very simple, as you can see, the volume, calculation of volume, which also include the uncertainty involved with the calculation. And some people also sometimes, increase this volume by 30% or 50% if there is a lot of uncertainty. Then apart from excreta, there is a chance some of the solid waste might dump into the pit also. In that case, just to increase the volume of the pit. But this is a simple calculation, as you can see. After calculating the volume, what is required, you have to assume what should be your plan. I mean, the shape and size of your superstructure. I mean, the squatting plan into the hole. So, how much area you are taking, whether it is a circular, whether it is a rectangular. This means this plan area you have to decide. And if you can remember, in one slide we showed you in pit latrine, normally or generally the dimension is 1 to 1.5 meters, not more than that, because sometimes more than 1.5 meters soil cannot really sustain that much of void without any support. In that case, normally we keep it. Even if it is more than that, sometimes superstructure cost is also high. So it's roughly 1 to 1.5 meters. So if you know that, then you know the plan area. The plan area is known. If you V divided by A, basically gives you the sludge depth. During the operational life, or 30 years or 50 years of time, then what should be the depth of sludge coming in? And one is the soil seal depth, number 2 point, if you can remember. We just discussed before this slide. This is the basically taken as 0.5 meter. 0.5 meter is roughly 1.5 feet, something like that. So in this case, in case of the double pit latrine, it is the depth to the bottom of the inlet drain. So we come back to the double pit system later on. But this is basically the seal depth. This means over that I showed you in the D. So basically this is basically the D, soil seal depth. It's commonly taken just to prevent or avoid surface pollution or surface contamination. And then infiltration area, we have to calculate. In communities where people use water for anal cleaning or bath in the toilet, a considerable amount of water may enter into the pit. So this is going your excreta disposal. So V equals to PNR, it's just excreta. Sometimes those people using water for anal cleaning and also bath in the toilet. If I bath in the toilet, that water also going to the pit. A considerable amount of water may enter the pit. If it is assumed that the soil pores below the sludge surface are blocked, then additional wall area must be allowed for infiltration of the liquids above the sludge. If we do not do that, then there is a high chance it can be fill up very quickly, and then infiltration is much lower than expected. Then it comes on the top very quickly. The infiltration area cannot include the soil depth since top 5 meter of a pit has a fully sealed line. So this 0.5 meter, I mean, as D, as you can see, some of the surface, wall surface along this 0.5 meter of soil depth cannot be used as infiltration area. So that infiltration area must be minus that 0.5 meter. So that 0.5 meter fully lined or sealed. It's not allowed infiltration. Assuming that all the liquid entering the pit lies on the top of the sludge, then the liquid depth will rise until the area of the contact between liquid and soil is large enough to permit infiltration of daily intake of the liquid. Then we have sludge depth, we have soil seal depth, we have infiltration depth, and these all together makes the pit depth. So pit depth is basically sludge depth. If there is any infiltration, then you have to accommodate the infiltration plus, and then you have soil seal. If you do not have any infiltration, just sludge plus soil. If you have infiltration, then you can infiltrate. So the summary of all the depth will give you the total pit depth. And this is how now we started our calculation. And as you can see here, a family of 6 members which intend to dig out a pit latrine with an operational life of 20 years. The family uses newspaper and corn cobs for anal cleaning. And salace is disposed separately. Salace means the water which is used in a kitchen or any other non-potable purpose, for example, shower, bath, washing. So that water is kitchen waste is called salace. So it says salace is separated. That means no bathing, no infiltration, basically not that much of infiltration, because people are not using even water for anal cleaning, just only urine and sludge is basically the fact here. So as you know, the family of 6 means P is given 6, operation like 20 years, N is given, and what is not given is the sludge accumulation rate was not given, where these people are living is not given, what type of diet they are producing is not given. So that means in that case, where is the water table is also not given. So then it's very difficult to assume what I will, which figure or which number I will choose. In this case, as you can see that operational life is 20 years. 20 years is quite huge. In 20 years of life, obviously huge amount of changes, huge amount of sludge will be generated, and no doubt about that. As we do not know the water table, okay, so the accumulation rate cannot be determined without some knowledge of depth of water, whether the sludge will be retained in water, whether sludge will be trapped. So assuming this is greater than likely pit depth, an accumulation rate of 60 liter per year is usual. Again, you may ask the question, why 60 liters? Why not 90 liters? So there is no judgment of such basically, but you have to start anyway. So then you can see what is the depth going on, and if it is necessary, then you have to revise the calculation, or sometimes in the exam is revision of calculation is not recommended. What you can do, you can rather discuss your result. So that will be fine. So let's say if we use 60, then obviously volume of sludge will be 6 is the people number, N is 20, P is 6, and R is 60 liter per capita per year. So this liter can be converted into cubic meter by dividing 1000, then it becomes 7.2 cubic meter. Then you have to choose the pits, whether it can be circular, whether it can be square, whether it can be rectangular, whatever you want. So anything between 1 to 1.5, let's say I choose 1.3. Circular in nature, that means I know the area. So plane area will be obviously pi d square by 4, so 4 goes up. Volume divided. So this is the depth required for the sludge for 20 years, 6 people using this toilet. Sludge generation rate is 60 liter per year. So 5.42 is quite huge. So almost closely 18 feet. Or let's say approximately 20 feet. 20 feet is quite huge depth. So if you go to 20 feet, obviously I believe you will have the groundwater table. The groundwater table is, except in the hilly area, the groundwater table is within 8 to 10 feet. If it is a case of Bangladesh, then obviously 8 to 10 feet you will see the groundwater. If you dig out even sometimes digging out 5 feet soil is also you can have water. So it's so high groundwater. So a pit of this dimension would mean that most of the sludge would collect below the water table. Therefore, the volume should be recalculated using a sludge accumulation rate of 40 liter per year. I'm not saying you have to do that in exam. I'm just showing you when you do it in a professional way, then how to basically calculate or how to recalculate, how to revise your design. So that is, as I said, if it is in Bangladesh, if you go to the approximately 20 feet from the EZL, then obviously we will have a chance there is a very high chance you will see the water present in the peat. So in that case, water will be retained. So in that case, faster biodegradation means lower generation. So I use 40. So if I use 40, then I recalculate the volume and recalculate the depth. So depth drastically reduced, as you can see, 3.62, roughly 10 feet. Then infiltration rate, as you know, the infiltration capacity of fine sandy soil. This means soil. If I go back to previous slide, there is no data for soil also. So just assume. You can assume by yourself also any data. So I said the infiltration capacity of a fine sandy soil, because what we do not want higher infiltration rate, because higher infiltration rate there is a more chance of groundwater pollution, because in this case we can see that what sludge will be retaining water. So there is still there is a chance already is here for the groundwater pollution. So that's why we keep it with a fine sandy soil. So we assume 33 here. So any value, I keep it in a intentionally without the value from the figure. You can see this is 50, then 35, 30, 25, 20, 10, below 10. So any value you can assume rationally, basically. So let's say if it's not given, you can use 30, even 30 is also fine. 33 square liter per day. And assuming the volume of water entering the pit each day is 200 liter, then infiltration area required will be this. 200 by 33, this means 6.1 square meter. And if we use the circumference of this circular trench, then circumferential area is obviously pi into d. You know, the circular circumferential area is pi into d. So pi into d is 1.3. In this case, you can see that liquid depth required is 1.49 meter for infiltration. If there is a chance of infiltration, if there is no chance, then you can reduce. I just put it to show you what sort of things may come in. So in this case, infiltration is not required because there is no infiltration basically, because people are not using water, and salage water is separately disposed of. But just to show you, if there is infiltration, then how you have to calculate this infiltration volume in terms of depth. So, and you know, total depth is include the soil seal depth 0.5 meter, and that approximately 5.61 meter. I mean, in a chota, it goes to 5.6. If we do not use this infiltration, then maybe 3.6 and 4 point something basically is the total depth is required. So bearing in mind that the inaccuracy of the basic design data, however, it is not necessary to carry out more accurate. So it is always better if we understand which area toilet is being to be installed and how this water is basically will be used, and what type of people will manage it. So some data from the field is better to be collected before design the company. So this is one part of the design, as you know. So there we have a squatting plan, we have a superstructure, but in this exercise we normally concentrated on the pit only. So right now it is the time to do another exercise by yourself. As I said, the exercise, as you can see here, with some calculation I have already presented. An offset port flush double pit latrine. Port flush means people use water. Is a double pit. This 2 pit is to be constructed for a family of 6. Again, 6 people. We use water for anal cleansing. So it's a port flush. This means you clean your water toilet by water, and also you use anal cleansing water for anal cleansing. The groundwater table is within 0.5 meter of the surface during the rainy season, and soil is a sandy seed. So little bit more informations are given here. And could you please do your calculation? This calculation may not necessarily matching with my knowledge. So you can assume yourself, and I will back to you following your roll number. As I said, I'm giving you the 5 minutes time. So it's 10 past 11. So we'll be back on 15 past 11. to take your response. So the roll number will be called, will show your result or discussion. So how you assume this? I may not cover all of you, but randomly I will ask 5 or 6 people, and then we'll show the result and going for the discussion. Okay, so please try to calculate by yourself, and we'll be back in by 5 minutes time. You finish your calculation, then we'll call you by using roll number. So whatever, right or wrong, what you understand, what is your understanding about today's class, you will just calculate. It doesn't take more than a couple of minutes maybe. So please do that. হ্যালো, হ্যাঁ 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 আসবো, এই ক্লাসে তো 11:30টার দিকে আসবো। একটু বলে দেবো ক্যান্ডিডেট 11:30।
Wait, be sure একটার জন্য ডাবল পিছনে 40 ইয়ার। ও বাসো এটাও হবে না। কি আমি অ্যাম্পিয়ার দেই 6 জন দিলাম, 2 বছর দিলাম, 40 দিলাম। 40 into 2 into .48 4 divided by 0.611.
Okay, so can we check your feedback? Are you okay? Ready? Some of you? Are you ready?
Infiltration.
Because today total participant is also not very much. I mean, it should be 90, no? Total student 65 and or 80. 65 and 15, so it should be 80. So 65 students. So, let's see. Anyway, can I start calling?
Sir, can you please open the previous slide? Just the previous slide.
We need the slide. You mean this one?
No, sir, the previous of this one. Previous of this.
This one.
Yes, sir, this one.
এটা তাহলে এইভাবে চিন্তা করাই যাবে না। 33 না আমি চিন্তা করলাম।
Okay, sir, done.
বলছে পোর্টরাস তো পানির পরিমাণ কি?
Okay, so let's start. I think. Then finally we'll be discussing what results we got and where the something goes wrong, or maybe you are presented well. So can we just start from roll number 5, 16, roll number 5.
Yes, sir.
Okay, so can you tell me the result you have got?
So if we
So all of you tell me. I mean just give me a second. Slash depth, infiltration depth. Okay, so this is what is necessary, and other soil seal depth is more or less fixed. Sometimes you can choose, but you just tell me slash depth and infiltration depth. How much you got for slash and how much you got for infiltration?
So for the sludge depth, I got 0.5 meters.
5 meters.
And infiltration depth is so infiltration depth 2.6 now infiltration depth is I haven't finished the calculation for the infiltration depth yet.
Oh, you haven't finished the calculation. Okay. So let me go somewhere else. 16,008. 16,008. Are you here? Maybe no. Okay.
Yes, sir.
Oh, you here? Okay. So how much you got for slash depth?
0.54 meter.
0.54. And infiltration, did you calculate?
0.74.
0.74 meter.
If I assume 100 liter.
Yeah, okay. That is what will come back. I mean, you calculated based on your justification and the data given, so we'll be fine.
Yes, sir.
So we can discuss, I mean, back on later, just to see how we can approach it. So can we little bit go up 1620, roll number 20? Are you here?
Yes, sir.
Okay, so how much you got?
স্যার স্লাজ ডেপথ পেয়েছি হচ্ছে 0.5 মিটার। যদি আমরা 1.2 বাই 1.2 ধরে নিই, মানে রেক্টেঙ্গুলার ধরে নিই, আমি রেক্টেঙ্গুলার ধরেছি, বাট যদি সার্কুলার ধরি তাহলে চেঞ্জ হবে।
হ্যাঁ, তুমি যেটা ধরেছো সেটা বলো।
জি স্যার, স্লাজ ডেপথ পেয়েছি 0.5 মিটার। আর ইনফিল্ট্রেশন ডেপথে প্রথমে আমি এটা আসলে স্যার কমপ্লিট করিনি।
Okay, so you still are doing?
জি স্যার।
Okay, carry on. Can I roll number 29?
Yes, sir.
Okay, so how much you got?
So sludge depth পাইছি sir 0.5 meter. আর infiltration depth sir এটা 0.5 meter also.
0.5 meter. So those who are coming as a discussion, please keep your audio on, because we have to take the variation, how much variation you got and what you did. So we cannot cover all of them in today. So, but every classes will be called on. Okay, so to you to come and discuss. So can I now go back to our people from 161001? Are you available? 161001.
Sir, our role 1 doesn't present. নেই, একদমই নেই।
So he's not here in this course.
Yes, sir. He is
Okay,
not here.
so roll number 2 in this case.
Yes, sir.
How much you got?
Sir, class depth 0.5 and infiltration rate also 0.5.
Please give me. Yeah, say. 5 সিকিউরিটি দিতে বলো, ওটা মনে ভালো হয়, ওখান থেকে তুলে দিই, তাহলে ওভার হেডে দিতে বলো, যে মহিউদ্দিন ওভার হেডের অ্যাকাউন্টে দিলে ওটা দিয়ে দিলে, তুলে দিয়ে দিলে, শোনা দিলাম ওটা। যদি মহিউদ্দিনের জানতো অ্যাকাউন্ট নামটা কি, ওই অ্যাকাউন্ট নামটা তো ঠিক হইতে হবে। হ্যাঁ, রাইট। না না, সমস্যা নেই, সমস্যা নাই। হ্যাঁ, okay, sorry, I've just called. So 161015 15, did you get?
Sir, 15 nahi sir, 14 last.
14 last. 14 আছো?
Yes sir.
তুমি কত পেয়েছো?
Sir, আমি পাই স্যার 0.36 মিটার। স্যার যদি ওই এটা আর এর ভ্যালুটা স্যার 40 ধরে।
তারপর নেক্সট।
আর স্যার ইনফিল্ট্রেশনটা স্যার মানে স্যান্ডি সয়েল ধরে করলে আর 100 যদি ধরি ইনফিল্ট্রেশন পার ডে, ওই হিসাবে স্যার আমার আসতেছে স্যার 0.7 মিটার।
Okay, I think for today is okay. All right, so now we go back to the slides. I will discuss the first what I have put, and then I will open up the discussion. So it is worth taking. So as you can see here, what I assume here, I assume R equals to 60 because ground water table is very high, 0.5 meter as you know. So, and 2 years is the design life. So I assume because it's a double pit latrine, so it's not saying how many years it will be used for. Since it's a double pit latrine, normally the design life for pit latrine is 1 to 5 years. So now you can say me that in previous example it shows 20 years. This is all about basically, I mean, depending on the condition, but normally it is an informal way of doing the excreta management. So that design life is 1 to 5 years. So I assume 2 years. Maybe you assume 5 years. So result might be well. Just see the procedures how we do that. So if I use 2 years, then we have 0.72 cubic meter. Here also I use square 1.2 meter by 1.2 meter, just because we add in the previous we see the circular, so we see 1.1 1 by 1, so then you got 0.5 meter. Some of you also got 0.5 meter. I'm not sure whether you assume in the same way or not. 0.5 meter. And infiltration depth I basically used in a two part. So one is since this is an offset 4 flush latrine, so I use 3 liter per flush. So every time you go to the toilet, then you use the flush, and if it is, you know, this water is basically 3 to 5 liters per flush, depending on the flush volume, tank volume. So if I assume 20 flushes per day for all 6 people using the toilet, then it becomes 60 liters. And then if 6 liter of urine, 6 liter means 1 liter per person per day. So then 6 liter by 6 liter of urine enter into the pit each day. Then total daily inflow will be 60 plus 6, so 66. And infiltration rate of sandy silt. Sandy silt is given, the soil is given, basically sandy silt. And if you go to the table, this is basically 25 liter per square meter. And then infiltration area required is 2.6. And you know the circumference of the pit, if we assume the pit is fully unlined, then side is 1.2 and multiplied by 4. So odd 4 side will contribute to the infiltration. Then circumference is 4.8, then 2.6 divided by 4.8 is 0.5. Again, it is 0.5. And this is basically 0.5, 0.5. And then now I'll about this, soil seal value. So we assume here 0.2. So forget about 0.2. If you give even 0.5, then it becomes 1.5 meter. So it's the total slash depth. So now, before I go a little bit more, so I want to open again the discussion. So those who we called on, you may also take part in the discussion. Also, some of you calculated, obviously all of you I expect you calculate, and then you can also discuss about something. The way I calculate, if you are not clear, then way you calculate it, you are not clear, then we can discuss for another 5 minutes. If any one of you want to discuss.
স্যার আমার একটা কোশ্চেন ছিল।
Yeah, please.
স্যার সয়েল সিল ডেপথ বলতে এখানে যা বুঝাইছে আমি সেটা ক্লিয়ারলি বুঝিনি। এখানে বলেছে পিটের অপারেশনাল লাইফ শেষে আমরা একটা সাফিসিয়েন্ট স্পেস রাখবো যাতে আমরা হচ্ছে মাটি দিয়ে কভার করে দিতে পারি। এখন আমরা কি অপারেশনাল লাইফ শেষে পিটটা ক্লিন করি না, নাকি তার উপরে মাটি দিয়ে চাপা দিয়ে দিই? আমি বুঝতে পারিনি এটা।
Normally in the pit latrine, we do not have basically the cleaning mechanism. So in the rural area or in urban slum, there is a very less opportunity to clean your pit latrine, even though we cannot clean the septic tank. So in that case, cleaning of pit latrine is quite not very often, so I mean it's very unlikely we clean the pit. If you can clean the pit, then it's okay. I mean, you do not need the seal depth, so you clean it and then you can use it again. But if there is a space available, sometimes what we are doing basically is a more flexible way of building the pit. So we close that pit, we transfer the superstructure to other surrounding area or very close by. We dig out another pit, and that pit becomes basically solid. I mean, becomes as a part of soil after 5 or 6 years of time.
আর স্যার ডাবল পিট ল্যাট্রিনে সয়েল সিল ডেপথটা এখানে কি বুঝেছে আমি বুঝিনি। বলেছে যে ইট ইজ দ্য ডেপথ টু দ্য বটম অফ দ্য ইনলেট ড্রেন, এটার মানে বুঝলাম না। মানে ডাবল পিট ল্যাট্রিনের সয়েল সিল ডেপথটা আসলে কোনটা?
সো ডাবল পিট ল্যাট্রিনে যেটা হয় অনেক সময় সেটা হচ্ছে যে তোমার যেহেতু ডাবল পিট, তাহলে মানে ওয়ান পিট উইল বি ইউজ ফর 2 ইয়ার্স, দেন অ্যানাদার পিট উইল বি ইউজ ফর 2 ইয়ার্স। তো এই দুইটা পিটের মধ্যে একটা কানেকশন এস্টাবলিশ করা, মানে যদি কোনো কারণে ওই পিটটা ওভারলোডেড হয়ে যায়, তাহলে সেটাকে আমরা এখনই ফিল আপ করতে চাচ্ছি, ওইটার মধ্যে একটা ড্রেন পাইপ দিয়ে দেন। হ্যাঁ, দুইটা পিটের মধ্যে কানেক্টিং একটা পাইপ থাকে। ওই কানেক্টিং পাইপটা বেসিক্যালি ওইখানে ওই ড্রেন পাইপ হিসাবে কাজ করে, যেখানে তখন আমরা সয়েল ডেপথ থেকে অ্যাভয়েড করতে পারি। মানে ব্যাপারটা অনেকটা এরকম, আমি একটু ছবি দেখাচ্ছি। এটা অনেকটা এরকম, মানে একটা পিট থাকবে উপরে, একটা পিট থাকবে নিচে। হ্যাঁ, মানে দুইটা পিটের লেভেল একই রকম থাকবে, একটা ভার্টিক্যাল গ্রেডিয়েন্ট তৈরি করে সেই সময় তৈরি করে ওই উপরে ওই সয়েল সিল ডেপথটা মানে না দেওয়ার জন্য, মানে আমরা এই পিটটাকে পুরোপুরি ওই যে তুমি যেটা বললে যে পিটটাকে যদি আমরা ইউজ করতে চাই, তাহলে সেই ক্ষেত্রে যেটা করা যায় ডাবল পিটে, যেহেতু 2 বছর করে ইউজ হবে, 2 বছরে সয়েল স্টেবিলাইজড হবে, তখন কমপ্লিট ডিকম্পোজিশন হবে না, কিন্তু সেই পিটটাকে আমরা ইউজ করতে পারি। তো সেই ক্ষেত্রে তখন একটা ভার্টিক্যাল পাইপ থাকে, ওই এক পাইপ থেকে আরেক পিটের মধ্যে তখন ওই লিকুইড বা কোনো কিছুকে ট্রান্সফার করে ওই দিক দিয়ে ওটাকে আরো মোর ইনফিল্ট্রেশনে নিয়ে নেওয়া যায়। সেটাকে একটা বটম ইনলেট বলে আর কি, মানে টপ থেকে বটমে কানেক্ট করা থাকে, মানে সেটা একটা ল্যাট্রিন থেকে আরেকটা ল্যাট্রিনে যেন যেতে পারে টু অ্যাভয়েড দ্য সারফেস কন্টামিনেশন। আর তুমি যদি মনে করো যে না, আমি দুইটার মধ্যে কোনো কানেকশন রাখবো না, আমি সয়েল সিল ডেপথ দিয়ে দিব, সেটাও সম্ভব। মানে both ways can work, মানে
বুঝতে পেরেছি স্যার।
কে বলতে চাচ্ছেন?
আমাদের এখানে যে সাজেশন দেয়া আছে যে সাজেস্টেড ম্যাক্সিমাম স্লাজ অ্যাকুমুলেশন রেট, এখানে বলা আছে যে যদি পানি ব্যবহার করা হয় আর ডিগ্রেডেবল থাকে এবং ক্লিনিং ম্যাটেরিয়ালস যদি ব্যবহার করা হয়ে থাকে, সেক্ষেত্রে আমরা ম্যাক্সিমাম স্লাজ অ্যাকুমুলেশনটা 40 ধরতে পারি। এখন আমাদের এই প্রবলেমে দেওয়া আছে যে ডাবল পিট ল্যাট্রিন, তো আমরা কি এটাকে 80 ধরতে পারি? আমরা এখানে 60 কেন নিচ্ছি স্যার?
এটার অ্যানসার কে দিতে পারবে? ও যেটা বলেছে আমরা কেন 60 দিচ্ছি? If some of you can give the answer, আমরা কেন 60 দিচ্ছি?
স্যার 80 নিলে ভলিউমটা আরো বেড়ে যায়, তখন স্যার ডেপথ অনেক বেশি হবে, গ্রাউন্ড ওয়াটারকে এফেক্ট করতে পারে।
আর ও যেটা বলছে সেটা বলো না, 60 কেন নিলাম? তো তুমি যদি 60 ধরে থাকো, হোয়াট ইজ ইওর লজিক? ও এক্স্যাক্টলি ওই জিনিসটা জানতে চাইছে। why I am using 60?
স্যার আমি এখানে স্যার আরেকটা অবজারভেশন দিতে পারি, যেটা হচ্ছে স্যার যদি আমরা 80 ধরি এখানে করি, তাহলে স্যার ভলিউমটা আসে 0.96 মিটার কিউব আর স্লাজ ডেপথ আসবে 0.568। তো যেখানে 60 ধরলে 0.5 আসতেছে আর এখানে 0.56, খুব বেশি ডিফারেন্স নাই, কিন্তু তারপর স্যার কেন আমরা এটা নিচ্ছি?
আচ্ছা, প্রথমত এটার যেটা কন্ডিশন সেটা হচ্ছে যে whether waste will be retained in water or waste will be in dry.
জি স্যার।
So if waste is retained in water, then highest you can take 60.
Okay.
If I show you this, can you see this slide? তুমি কি এই স্লাইডটা দেখতে পাচ্ছ?
জি জি স্যার, আমি দেখতে পাচ্ছি, আমার কাছে লেখাও আছে স্যার এটা।
হ্যাঁ, এই যে দেখো এই স্লাইডে লেখা আছে, উপরে দুটো হচ্ছে ওয়েস্ট রিটেন ইন ওয়াটার। হ্যাঁ, মানে এখানে তো গ্রাউন্ড ওয়াটার টেবিল খুব উপরে না, 0.5 মিটার ইজিএল।
জি স্যার।
হ্যাঁ, সেই ক্ষেত্রে এই দুইটা কিন্তু ড্রাই কন্ডিশনে, মানে ড্রাই কন্ডিশনে 60, 90, মানে ড্রাই কন্ডিশনে স্লাজ অ্যাকুমুলেশন রেটটা বেশি। আর এখানে হচ্ছে ওয়েট কন্ডিশন, ওয়েট কন্ডিশনে আমরা হাইয়েস্ট নিতে পারবো 60 যদি ডাটা না থাকে। হ্যাঁ, ওয়েস্ট রিটেন ইন ওয়াটার, এটা হচ্ছে ওয়েস্ট রিটেন ইন ওয়াটার, বুঝছো?
জি স্যার।
তুমি 80 নিতে পারবে যদি তুমি সার্ভে করে দেখো যে আমার ওইখানে সার্ভেতে 80 আসতেছে, মানে অ্যাকুরেট ডেটা যদি তোমার কাছে থাকে, ইউ ক্যান টেক, নো প্রবলেম। বাট ইন অ্যাবসেন্স অফ ডেটা, ইটস বেটার টু ইউজ দ্য রেফারেন্স ডেটা। বলো তারপর নেক্সট।
স্যার, আমি কি ধরনের কম্পোনেন্ট ব্যবহার করতে পারি পিটের দুই পাশে? আপনি যেটা বলছিলেন যে লাইনিং ম্যাটেরিয়ালস এর কথা, এখন স্যার এইটা এই লাইনিং ম্যাটেরিয়ালস এর উপরও তো আমার মনে হচ্ছে অ্যাকুমুলেশন রেটটা নির্ভর করবে।
না, অ্যাকুমুলেশন রেটটা সেটাই হবে যেটা আমরা 60 ধরলাম, বা তুমি 40 ধরতে পারো, মানে সেফটি কম রেখে বা ফ্যাক্টর অফ সেফটি কম রেখে। বাট লাইনিং ম্যাটেরিয়ালটা হচ্ছে টু প্রটেক্ট দ্য এনভায়রনমেন্ট, মানে এখানে যেমন 0.5 মিটারেই আমার গ্রাউন্ড ওয়াটার, সেটা যদি আমি ওই ওয়াটারটাকে যদি আমি ড্রিঙ্কিং পারপাস ইউজ করি, তাহলে অবশ্যই আমাকে প্রোটেক্ট করতে হবে যে আমার টয়লেট থেকে, আমার পিট থেকে, আমার শ্যালো টিউবওয়েল বা যে টিউবওয়েলে পানি আমি খাচ্ছি সেটা ডেপথ কত, বা হরিজন্টাল ডিসটেন্স কত, ইজ দেয়ার এনি চান্স টু প্রোটেক্ট দ্য গ্রাউন্ড ওয়াটার নেসেসারি, তাহলে তোমাকে সেখানে লাইনিং ম্যাটেরিয়াল দিতে হবে। লাইনিং ম্যাটেরিয়ালটা আসলে কিছু না, এটা এক ধরনের ফিল্টারের মতো কাজ করে। এটা পিটের ওপেন যে সয়েল আছে সেটাকেও সাপোর্ট দিল, পাশাপাশি হরিজন্টাল যে মুভমেন্টটা আছে, পলিউটেন্টের মুভমেন্টটাকে সে আটকাবে, মানে কিছুটা ট্রিটমেন্ট দিবে সে আর কি। মানে আমরা মনে করতেছি যে এখানে প্যাথোজেন বা যে ধরনের ব্যাকটেরিয়া বা ভাইরাস গুলো আছে, there is a chance it can transfer to the deep tubewell or tubewell we are using. In that case we will protect a barrier. তো ওইটার সাথে আসলে স্লাজ অ্যাকুমুলেশনের কোনো সম্পর্ক নেই। ওটার সাথে সম্পর্ক হচ্ছে আমি যদি গ্রাউন্ড ওয়াটারকে প্রটেক্ট করতে চাই, তাহলে সেইখানে আমাকে একটা মেকানিজম তৈরি করতে হবে। ঠিক আছে?
জি স্যার। স্যার, যখন ডিজাইন করা হয়, ইঞ্জিনিয়াররা যখন ডিজাইন করেন আপনার পিট ল্যাট্রিন, সেক্ষেত্রে একটা ডিজাইন লাইফ আমাদেরকে ধরে নিতে হবে, বা ইফেক্টিভ অপারেশনাল লাইফ যদি ধরি। স্যার, এখানে আমরা একটা ম্যাথ দেখলাম 20 ইয়ার্স, একটা দেখছি 2 ইয়ার্স। এখন স্যার এটা স্ট্যান্ডার্ডটা কত ধরে নেওয়া হয় নরমালি?
আচ্ছা, এখন 20 ইয়ার্স তুমি ধরতে পারবে, এবং স্বভাবতই যেটা খুব ভ্যালিড একটা কোশ্চেন, আমরা যদি 20 ইয়ার্স ধরি তার মানে হচ্ছে আমি 20 বছর এটাকে অপারেশন নাই, মানে ইটস কোয়াইট লং অপারেশন।
জি স্যার।
তাহলে অবশ্যই এমন একটা জায়গায় সেই পিটটা করতে হবে যেখানে 20 বছরেও আমার গ্রাউন্ড ওয়াটার পলিউশন হবে না এবং নেসেসারি চেঞ্জেস উইল বি ভেরি লো। ধরো আমি খাগড়াছড়ি, বান্দরবনে একটা জায়গায় করলাম যেখানে পপুলেশন কম, গ্রাউন্ড ওয়াটার টেবিল অনেক নিচে, এবং আমার ওই ধরনের পলিউশন এবং ওইটা মেনটেন করা খুব ডিফিকাল্ট, ওই জায়গায় এটা হতে পারে। বাট আমি যদি আরবান স্লাম এরিয়াতে করি যেখানে গ্রাউন্ড ওয়াটার হাই, পপুলেশন ডেন্সিটি ভেরি ভেরি হাই, চেঞ্জেস আর ভেরি র্যাপিড, হ্যাঁ আজকে এখানে আছে কালকে ওইখানে থাকবে না, তাহলে সেই ক্ষেত্রে কমনলি টিপিক্যালি পিট ল্যাট্রিনস লাইফ, ডিজাইন লাইফ ইজ 1 to 5 years.
1 to 5 years.
1 to 5 years. Exceptionally is too long if the conditions exist. In a remote area, সবকিছু ঠিক আছে, পপুলেশন ডেন্সিটি কম আছে, পলিউশনের রিস্ক কম, সেক্ষেত্রে তুমি সাজেস্ট করতে পারো। আনটিল অর আদারওয়াইজ 20 ফিট একটা পিট ডেপথ করা আসলে সয়েলের মধ্যে এটা ইজ কোয়াইট ডিফিকাল্ট, মানে এটা অনেকটা আনরিয়েলিস্টিকও বলতে পারো তুমি, মানে ইটস নট দ্য ভেরি কমন টাইম। জাস্ট এক্সারসাইজ মানে ডিজাইন করার জন্য আমরা করেছি, বাট নরমালি 1 to 5.
ওকে।
এনিথিং এলস?
স্যার, আমরা ইনফিল্ট্রেশন ডেপথ বের করার সময় একটা পেরিমিটার দিয়ে এরিয়াকে পেরিমিটার দিয়ে ভাগ করি। তো ওই পেরিমিটারটাকে আপনি বলেছেন 1.2 into 4 করেছি, কারণ চারদিক দিয়ে ইনফিল্ট্রেশন হচ্ছে। এখন পিটে কি উপর দিক দিয়ে ইনফিল্ট্রেশন হয়? আমরা তো জানতাম জাস্ট বটম আর সাইড দিয়ে ইনফিল্ট্রেশন হয়,
মানে তিনটা সাইড আছে।
জি স্যার, তো আমরা 4 দিয়ে কেন গুণ করলাম?
ভালো একটা, আমি নিজেও এটা চিন্তা করি, মানে unless or until it is closed, so we normally do not allow water to be. So এটা মানে নির্ভর করছে তোমার যদি আসলে পিটটা যদি তোমার মানে ইয়ে হয়, মানে ধরো মানে ক্লোজড হয় চারদিকে, মানে এইখানে আসলে যেটা প্রবলেম হচ্ছে সেটা হচ্ছে যে এখানে কিন্তু গ্রাউন্ড ওয়াটার টেবিল অলরেডি হাই না 0.5 মিটার। তার মানে আমরা ধরে নিতে পারি যে আমাদের যে স্লাজগুলো সেগুলো কিন্তু আসলে অলরেডি পানির মধ্যেই থাকে। হ্যাঁ, পানির মধ্যে থাকলে হয়তো সেটা, বাট আই টোটালি অ্যাপ্রিশিয়েট, মানে তুমি এটাকে আউট করে ধরলে আসলে 3 দিয়ে গুণ দেওয়াটা অ্যাপ্রোপ্রিয়েট। মানে
স্যার
আই টোটালি এগ্রি উইথ।
স্যার চারদিকে 4টা সাইড আছে তো, রেক্ট্যাঙ্গেল আর স্কয়ার হলে তো স্যার 4টা সাইড আছে না?
হ্যাঁ, এটা ওই যে আরেকটা সরি আরেকটা ব্যাপার হচ্ছে ওই যে তুমি 3 ডাইমেনশনটা যদি আমরা ধরি, মানে ও আরেকটা পয়েন্ট ঠিক আছে।
তাহলে স্যার বটমটা কাউন্ট করব না?
মানে তুমি এখানে বটম তো কাউন্টে আসতেছে। তোমার টোটাল সাইড তুমি দেখো কয়টা সাইড, তোমার 1টা 2টা 3টা এরিয়া করে যদি পেরিমিটার করে যদি করো 4টা। না, আমার মনে হয় যে ইয়ের পয়েন্টটা ঠিক আছে। এই তোমার কি নাম বলো তো, একটু ভুলে যাই। ওই যে 3টার কথা বলেছো তুমি।
স্যার আমার নাম ঐশ্বর্য।
আচ্ছা, আমার মনে হয় এটাতে কোনো প্রবলেম নাই, মানে 3টা ধরলে যেটা হবে ওইখানে আরেকটু বাড়বে ডেপ, ঠিক আছে? মানে 4টা সাইড যদি অ্যাভেলেবল না, এটা কিন্তু আরেকটা এটার সাথে মোর রেলিভেন্ট আমি বলি, যদি কোনো কারণে পিটটা সেলফ সাস্টেনেবল না হয় তাহলে কিন্তু এমনিতেও লাইনিং এরিয়া কমে যাবে। আর তুমি যদি ধরো আমাকে ওই পিটটা থাকতেছে না, তাহলে পিটটা না থাকার কারণে আমাকে যদি ওইখানে মানে কংক্রিট ওয়াল করে দিতে হয় বা ব্রিক ওয়াল করে দিতে হয়, তাহলে কিন্তু আমার শুধুমাত্র বটম থাকে, সেক্ষেত্রে কিন্তু শুধু আমার একটা সাইড থাকে। বুঝতে পারছো? এটা আসলে ফিল্ড কন্ডিশনে জাস্টিফাই করতে হবে। We can talk about this a lot. I always prefer discussion. তো তোমাদের যদি কোনো কোয়েরি থাকে একটু লিখে রাখো। আমার একটা ছোট্ট একটা ইন্টারভিউ আছে এখন এই 11:45। হ্যাঁ, একটা রিসার্চ অ্যাসিস্ট্যান্ট নিয়োগের ভাইবা আছে। So I have to go to the VC office. So I left with you with this discussion. Hopefully will be more fruitful discussion in the next class when we'll start our main themes like wastewater treatment, which is quite important nowadays. আমি তোমাদেরকে বারবার বলেছি ওয়েস্টওয়াটার ট্রিটমেন্টটা ভালোভাবে বোঝার জন্য, কারণ হচ্ছে এখন কিন্তু আমরা ওয়েস্টওয়াটারের উপরে জোর দিয়েছে সরকার এবং আমরা এসটিপি বিল্ড আপ করছি। এই লাইনে তোমাদের নলেজটা কিন্তু আমি চাই যে অ্যাটলিস্ট বেসিক নলেজটা যেন ক্লিয়ার থাকে অ্যাবাউট বায়োলজিক্যাল ডিগ্রেডেশন অফ ওয়েস্টওয়াটার, কিভাবে আমরা সেটা করি, ফিজিক্যাল, কেমিক্যাল অ্যান্ড বায়োলজি। আমরা কেমিক্যালে যাব না, আমরা ফিজিক্যাল অ্যান্ড বায়োলজিক্যালে। তো আশা করি নেক্সট ক্লাস থেকে এগুলো আমরা আরেকটু করবো। আর আমি নেক্সট ক্লাস থেকে তোমাদের ক্লাসগুলো আমি ক্লাসরুমে নিব, সো দ্যাট আই ক্যান ইউজ দ্য বোর্ড টু ইভেন মেক ইট মোর ইন্টারেক্টিভ। আচ্ছা, এখন তোমাদের মাইশা ম্যাডাম একটু তোমাদের সাথে কথা বলবে এই অনসাইট স্যানিটেশনের উপরে। আমরা একটা ডেমো একটা কুইজ নিতে চাচ্ছি, মানে জাস্ট টু মেক শিওর যে আমরা ক্লাস টেস্টটা কিভাবে নিতে পারি গুগল ক্লাসরুমে। তো উনি এটা রেডি করবে, তোমাদের একটা ডেমো ক্লাস টেস্ট আমরা নেক্সট ক্লাসে নিব।